Hi everyone, welcome back to Performance Testing Mentor channel. This is part 3 of Memory Leaks in Performance Testing series. Before we dive in, a quick note. Most of the viewers aren't subscribed yet. If you are enjoying the content, hit that subscribe button. Alright, let's get started. In part 2, we explored how the JVM divides memory into heap, stack, and metaspace. But memory doesn't clean itself. That's where the garbage collection comes into the picture. As a performance tester, understanding how the garbage collector works is crucial because leaks usually reveal themselves through abnormal GC patterns. Let's try to understand what is garbage collection. Garbage collection or GC is the JVM's way of cleaning up unused objects to free memory. Think of it like housekeeping in our e-commerce app. A customer browses 50 products and temporary objects like product images and search results are created. Once the user leaves the page, those objects are no longer needed. The garbage collector automatically identifies them and reclaims the memory. Unlike in C or C++, developers don't need to manually free memory in Java. But that doesn't mean it's free of leaks. If an object is still referenced, GC won't touch it. Now let's look at the types of garbage collector events. These are majorly divided into three different types: minor GC, major GC, and full GC. Minor GC is the one which is going to clean the young generation. These are very frequent and happens in milliseconds. Example here is in our e-commerce app, each new search creates objects. When hidden fills, minor GC clears them. Next one, major GC. This is also called as old gen GC, which is going to clean the old generation. These are less frequent but takes more time. Example, if the cart object keeps references even after checkout, it survives into old gen. Major GC will eventually try to clean this. Next one, full GC, which is going to clean the entire heap, which includes the young plus old plus metaspace. These are most expensive, can pause the application for noticeable time. Example, during Black Friday load test, if memory keeps filling due to leaks, a full GC may freeze checkout for several seconds, causing users to abandon carts. Let's try to understand how the garbage collection has a direct impact on performance testing. During GC, application threads may pass and it will cause some pass times. A short 50 milliseconds pass isn't noticeable, but a 5-second pass during checkout can kill conversations. When it comes to the throughput, frequent GC reduces system throughput as more CPU is spent cleaning instead of serving the users. Latency spikes. In the load test results, if you see a sudden spike in response time, it might align with full GC events. If we take an e-commerce app example, under 5,000 virtual users, checkout response time jumps from 2 seconds to 15 seconds. A GC log shows a full GC of 8 seconds at the same time. That's a red flag. Now let's have a walkthrough of common garbage collectors along with pros and cons. The JVM provides different garbage collectors, each with trade-offs. As a tester, you don't configure them, but you must recognize their impact. Here are the different types of garbage collectors along with its pros and cons. My suggestion is just pause the video here for few minutes and try to understand the pros and cons of each garbage collector type that is available over here. For an e-commerce application under heavy load, G1GC is the most common choice here. How testers detect GC issues. As performance testers, your job isn't to configure GC, but to identify GC related issues in test results. Here is what to watch for. In your test, if heap usage is rising without dropping after GC, then there is a possibility of leak that you may see going forward. If two frequent minor GCs are happening, then we can say like your application is going to create excessive short-lived objects, which will lead to memory leaks. If you are able to see repeated full GC, then there is a possibility of leak in old generation. If there are long GC pauses, then you can see like latency spikes, which is going to be visible in test reports. In our e-commerce test, if checkout times keep climbing while heap graph shows constant growth, you know a leak exists. To summarize, garbage collection keeps your app healthy by cleaning unused objects. But when objects escape GC, memory leaks happens. In part 4, we'll move from theory to practice. How to detect memory leaks during performance testing using tools, heap dumps, and monitoring dashboards. Thank you.